The topic is model selection. To find the optimal subset of predictors for modeling a response variable, we can do the following steps. Compute all the possible subsets ranging from 1 to z of x and evaluating all the models constructed from all the subsets and finding the model which is optimized. So exhaustive selection is computationally infeasible because we are doing all the combinations of values of x. So we will be going to the model selection. The model selection is an application of a principal method to determine the complexity of the models. Example, choosing a subset of predictors and choosing the degree of a polynomial model, etc. In forward selection, we find an optimal set of predictors by iterative building up. So model selection has a very less complexity when compared to the exhaustive selection, so which will be in the terms of big O notation j square, which is very much lesser than 2 to the power of j. And coming to the part regularization, the idea of regularization revolves around the modifying the loss function L. In particular, we add a regularization term that penalizes some specified properties of the model parameters. So mathematically, this is the equation for the loss function. So in this we have two regressions, one is lasso regression and another is ridge regression. So lasso regression, since we wish to discourage the extreme values in model parameter, we need to choose a regularization term that penalizes parameter magnitudes for our loss function. So we will use MSE again in this. So algebraically, the lasso function having this, and coming to the ridge regression, alternatively we can choose a regularization term that penalizes the squares of the parameters magnitude. Then our regularization loss function will looks like this. In Python, we will be importing sklearn linear models which consist of lasso and ridge functionalities. So with the help of these two inbuilt functions, we will be performing regularization.